Alright guys, so today we're going to continue on with our trig unit. As you can see, there's kind of a lot that we're going to talk about today, but it all kind of leads into one another. The first thing is really the most important, this first block out of the three, because you're going to use what we figure out here for the bottom two parts. So first, let's just talk about the unit circle. You've definitely heard of the unit circle before. What the unit circle is, obviously it's a circle whose radius, whose center, let's say that first, whose center is the origin, and the radius is 1 unit. Okay, so again, it's a circle whose center is on the origin, and the radius is 1 unit. So for example, if I have this circle, so if this is my circle here, the center of the circle is on the origin, and let's say I have this point here, the radius, which is the distance from the center to an end point, is 1. Okay, so we're going to use this to figure out rules for sine, cosine, and tangent. If you remember when we did sine, cosine, and tangent the other day, we called that right triangle trig. I don't have a right angle right now. I only have this circle. So what I'm going to do, what you're going to do on your paper, you're going to drop down what's called an altitude, and now you have this point here, and it's going to go right across. This point is going to be x comma y. And now this is my right angle, okay? So this distance right here, this distance is not 1 because it doesn't start at the center and go to the edge of the circle. This distance is whatever this x value is up here. So we're just going to call this x. Same thing with the y value. The y value is not from the center to an endpoint. So we're going to call that y, okay? This we're going to call theta. All right, so we're going to use this to figure out more about sine, cosine, and tangent on the unit circle. This is only when you're on the unit circle, okay? So if you remember the rule, the sine of theta is equal to the opposite divided by the hypotenuse. So if I look on my triangle right now, opposite theta is y. Opposite theta is y. I'm talking about this triangle right here, divided by the hypotenuse is across from the right angle is 1. So sine of theta is equal to y divided by 1, which is just y. So sine of theta is the y value for any point that's on the unit circle. Cosine of theta is adjacent divided by the hypotenuse. So if I look at my triangle, adjacent to theta is x, divided by the hypotenuse is 1, and x divided by 1 is x. And then lastly, we have tangent. So tan of theta is opposite divided by adjacent, right? That's TOA in SOHCAHTOA. So if you look at your triangle, the tangent of theta, we said opposite the theta is y divided by adjacent to theta is x. So tangent of theta, you can't clean that up at all, is y divided by x. However, you may see y divided by x written differently. We just said that y is sine of theta and and x is cosine theta. Okay? So sine of theta is the y value, cosine of theta is the x value, and tangent of theta is y divided by x, which can also be written as sine of theta divided by cosine theta. Now I know that all seems like super confusing. As long as you understand and you remember the rule, it really doesn't matter you understanding how we got there. I know it's weird because we're not in class right now for me to go in more depth to explain it. But as long as you know what's in these 3 boxes, you're okay. All right, so now we can use that to figure out why the sine of 0 degrees is what it is. Again, we're going to fill this chart in So you're going to do the sine of 0, the sine of 90, the sine of 180. Now, you can just plug these in your calculator. However, next year and in pre-calc, you're going to be expected to know them. And I'm going to show you why they are what they are rather than you just memorizing them. If you prefer to just memorize, then that's up to you. But again, it's not always going to be the best case for you to do that. So if I have my circle, so let me draw my circle down here. Okay, not the best, but it doesn't matter. If we look at 0 degrees is right here, right? That would be jutting off this way to the right. 90 degrees would intercept that point. 180 degrees would go through this point. 270 would go through this point. And 360 would go through the same point that 0 degrees goes through. So now, if you remember, this is on the unit circle, right? So all of these distances, because this is your center. I know, keep in mind, my circle, it does not look like a circle. All of these distances here are 1 because they're all going from the center to the end point. Okay? So if you go, for example, this first point right here, again, this represents 0 degrees and 360 degrees. If you go from the center to this point will be 1, 0. Because you moved once to the right and you didn't move up or down at all. This point up here for 90 degrees, that goes through 90 degrees, is 0, positive 1, because you didn't move left or right at all, but you went up 1. 180 degrees, this point is negative 1, 0, because you went to the left 1, and that's it. And then 270 degrees down here would be 0, negative 1. So now once you have this picture, watch how easy this is. I'm going to just fill in the entire column. I'm not going to go row by row. I'm going to go column by column for this. For 0 degrees, 0 degrees is this point. I'm going to highlight it. 0 degrees is this point right here, right? So to figure out the sine of 0 degrees, sine is the y value. That's what we did a second ago. Sine is the y value. The y value is 0. If you were to type into your calculator right now, sine of 0, and press enter, as long as your calculator is in degree mode, it's going to give you 0. Cosine is the x value. So cosine of 0 degrees is the x value, which is 1. And then tangent is y divided by x. So in this case, it's 0 divided by 1, but you're not going to write that. You're going to write 0. Okay? So sine of 0 degrees is 0, cosine of 0 degrees is 1, and tangent of 0 degrees is 0. And that's why they are what they are. Okay? If we try now, let's try 90 degrees. So 90 degrees is up here. Right? It goes through that point, which is 0, 1. So the sine of 90 is the y value, which is 1. The cosine of 90 is the x value, which is 0. And then tangent would be y divided by x. So 1 divided by 0. If you remember, whenever we divide by 0, that is undefined. If you try typing into the calculator tangent of 90 degrees, you're going to get an error message in the calculator. Can't do it. Okay? Let's try 180 now. So 180 is this point that's over here. That point is negative 1, 0. So the sine of 180 is the y value, which is 0. Cosine of 180 is the x value, which is negative 1. And tangent is y divided by x. 0 divided by negative 1 is 0. You only get undefined when 0 is in the denominator, in the bottom. All right, let's go to 270 down here. So 270, goes through the point 0, -1. So the sine of 270 is -1. The cosine of 270 is 0. The tangent of 270 is -1 divided by 0, which is undefined. You cannot divide by 0. Okay, 360, last one. So 360 is the same point, right? It goes through the same point as 0, and the reason why is because 0 degrees and 360 degrees are coterminal. So the sine of 360 is 0. The cosine of 360 is 1, because that's the x value. And the tangent of 360 is 0 divided by 1, is y divided by x, which is 0. Notice these two columns are exactly the same because 0 and 360 are coterminal. Okay? There's nothing really to do with this. Same thing as the first chart that we made. I can't really ask you questions other than what the answers are. Okay? I'm just trying to explain why they are what they are. Now, the only thing that's really different is the bottom, where the functions are positive and negative. So we know that, again, you need these rules for this. You need to know that the sine of theta is the y value, the cosine of theta is the x value, and the tangent of theta is y divided by x. Same rules that you wrote on the top of the paper. I'm just zooming in, so I want to make sure I have it down here too. That's only when you're on the unit circle. However, the rules still apply when you're trying to see where something's positive or negative. So let's just look at the first quadrant. In the first quadrant, right, you move to the right and up from the origin. To the right and up, which means if you move to the right, you have positive x values, and if you move up, you have positive y values. So anything in between 0 and 90 degrees, right? Anything in between 0 and 90 degrees, that point will be positive, which means if the y value is positive, that the sine is positive. Okay? So let's say you do sine of 45. 45 is in between 0 and 90, so it's going to be some positive number. The cosine is the x value, which means that the cosine is also positive. And then the tangent is y divided by x, or sine divided by cosine. Positive divided by positive is a positive. Okay? Now let's look in the second quadrant. In the second quadrant, you see degrees anywhere between 90 and 180 for the most part. It could be more, like we talked about the other day, but if you are in between 90 and 180, you're in quadrant 2. In quadrant 2, you move to the left and up from the origin. So when you move to the left, you have negative x values and positive y values. That means that the sine of theta in quadrant 2, sine is y, is positive. Cosine of theta in quadrant 2, cosine's the x, is negative. Tangent would be y divided by x, or a positive divided by a negative is a negative. Okay, let's go to quadrant 3. Quadrant 3 has angles in between 180 and 270. To go from the origin to something in quadrant 3, you went to the left and then you went down. So your x is negative because you went to the left, and your y is negative because you went down. That means that sine of theta is negative because of the y. Cosine of theta is negative because of the x. And tangent of theta would be negative divided by negative, which is a positive. And last quadrant, we have anywhere from 270 to 360, or you could have bigger angles, or you could have negative angles as well. Okay, 360. To go from the origin to something in quadrant 4, you move to the right and down. Because you move to the right, your x's are positive. Because you move down, your y's are negative. So we have sine, cosine, and tangent again. Because y is negative, sine is negative. Because x is positive, cosine is positive. And because tangent would be a negative divided by a positive, tangent would be negative. Okay? Now this is the phrase that we say. In quadrant 1, all of the functions are positive. In quadrant 2, only sine is positive. In quadrant 3, only tangent is positive. And in quadrant 4, only cosine is positive. So we have A, S, T, C. So I guarantee a phrase that your Algebra 2 teacher will use next year, that we're going to use now, is all students take calc. A, S, T, C, starting with the first quadrant, and then it moves around just like how you would move a positive angle around. Okay? So now questions that we would ask with this. We'll give you like 2 criteria, and then you'll tell us what quadrant it's in. So for example, letter A over here. Cosine of theta is less than 0. That means that cosine is negative, right? Less than 0 is negative. Sine of theta is greater than 0. That means that sine has to be positive. There's only one quadrant where cosine is negative and sine is positive. Now you can either look back at this and see what quadrant that is, or you can try to remember all students take calc and do it by hand. So this is what you would do. Remember, all students take calc is where everything is positive. So the first part, cosine is negative. Cosine is negative in the S and the T, because in quadrant 1 that would be all of them, and in quadrant 4 that would be positive. Sine is positive when they're all positive, and sine is positive where sine is positive, quadrant 2. Okay, so because quadrant 2 is the only one where both things work, this is in quadrant 2. Now, if that's confusing, I know it is confusing the first time that you do it, you can just look and see which one of these has these 2 things together here. You can do it that way as well. Letter B. Let's just try a few more. Letter B. Tangent of theta is less than 0. Less than 0 is negative. Cosine of theta is greater than 0, so positive. So if I draw my chart, tangent is negative. In quadrant 1, all of them are positive, so not quadrant 1. In quadrant 2, only sine. If only sine is positive, that means that tangent's negative. In quadrant 3, only tangent's positive. Well, I want to know where tangent's negative. In quadrant 4, only cosine is positive, which means that tangent has to be negative. Then the second part, cosine of theta is positive. In quadrant 1, they're all positive. In quadrant 2, only sine, which means no cosine. In quadrant 3, only tangent, so no cosine. And in quadrant 4, only cosine's positive. Quadrant 4 is your answer. Okay? Letter C. Let's try another. Cosine of theta is greater than 0. Greater than 0 means positive. Sine of theta is greater than 0. That means sine of theta is positive. So cosine's positive where they're all positive and where only cosine is positive. Sine is positive where they're all positive and where only sine is positive. Quadrant 1 is where the 2 check marks are. So my answer to letter C is quadrant 1. Last one. Tangent theta is less than 0. Less than 0 means negative. Sine of theta is less than 0, also means negative. So we're looking for where tangent and sine are both negative. So in quadrant 1, they are both positive. In quadrant 2, sine is positive, which means tangent's negative. In quadrant 3, we have tangent is positive. And in quadrant 4, tangent is negative. Moving on to sine is negative. Sine is negative. Quadrant 1, it's positive. Quadrant 2, it's positive. Quadrant 3, it's negative. Quadrant 4, negative. So your answer to letter D is quadrant 4. Okay? Let me know if you have any questions. Give your homework the best shot that you can. I know the bottom part's a little tricky, but again, you can just look right at the chart to figure out where what quadrant you're going to be in. Let me know if you have any questions. Have a good day.